Going on to topic 5 now of chapter 6, we're going to use some of the techniques we've developed to solve applications using rational equations. We'll be dealing with problems involving work, motion, and proportion. And once again, I remind you that I've put a number of examples in the additional examples section of our YouTube videos. Okay, here's a typical one in which we are involving work. Juan and Rebecca work during the summer painting houses. Juan can paint an average size house in 12 days, while Rebecca requires 8 days to do the same job. Looks like Rebecca's a little faster. How long would it take working together to paint an average size house? Well, for work problems, there is a sort of a general formula, and it's something like this. So what will Juan's average be per day? He can get 1/12 of the house done in one day. So that's his rate. Now, how long does it take Rebecca? 8 days. So in one day, she can get 1/8 of the house done. So these are their rates, Juan's rate, Rebecca's rate. And together, what will their rate be? Well, we don't know that. That's where algebra comes in. It's going to be 1 over t. Now, sometimes they modify this formula a little bit, but this is the one I like to use. So this is, if you know someone's rate, someone else's rate, this is the rate they're going to get it done together. And there are modifications of this. So how does it work out? Well, again, you have to solve for the letter t. You do so by multiplying each term by the lowest common denominator. I'm going to write it this way here, like we did in some of the other examples. I'm going to multiply every term by 12, by 8, and by t. Okay? This is the lowest common denominator. Now, actually, it's smaller than that because I probably could have used 24. And in fact, let's do 24. You could use this way too, but that's not the least common. Because between 12 and 8, the least common denominator is 24. So 24 times t. All right, 12 goes into 12 once. 12 goes into 24 twice. So we have 2t times 1, which will be 2t. Now 8 goes into 24 3 times. So this will be 3t. And t goes into this 24 times. That's all that's left. So this is the t's cancel out, and you're left with 24. So we add this up. Divide both sides by 5. And t equals, this is going to go 4 hours and 4/5. Or 24, well actually these are days, because that was our unit up here. Usually it's hours, but right now it's days. Okay? So to paint the average size house together would take them just under 5 days. All right, now let's watch them in action here. Familiarize yourself. Here they're just giving you a trial example to see how to do it. And again, I don't like the way they're writing these fractions here. Again, Juan gets it done, 1 out of 8. I'm sorry, 1 out of 12. Rebecca, 1 out of 8. And notice if you had it set up the way I did, where it was 1 over t, and you multiplied everything by t first, then it would end up like what we have here. I like my way. And they're saying here's how it looks on a calculator. And there's what t is. T is 24 fifths, or 4 4/5 days. And it checks out. So this is the formula I was using. And if you multiply everything by t, it gets this formula. Okay? They're equivalent. I like this one. All right, let's go on to problems involving motion. Because of a tailwind, a jet is able to fly 20 miles faster than another jet that is flying into the wind. In the same time that it takes the first jet to travel 90 miles, the second jet travels 80 miles. How fast is each jet traveling? Well, I'm going to give you some background on this. And the formula we use for this is distance equals rate times time. Now, this doesn't work too well in this case. And in fact, what do we know is the same in both? Well, we know that time is the same. So I'm going to solve for t by dividing both sides by r. So what does t equal now? T equals distance divided by rate. Okay? And we actually have two of them. We have time equals time. That part's the same. Well, on this side, it's going to be distance divided by rate equals distance divided by rate. So that's basically our equations here. So one plane is traveling 90 miles. That would be its distance. Now, we don't know the rate of the plane. That's going to be r. But we know with the help of the wind, it's 20 miles per hour faster. And then the other one flying into the wind is going to be 80 divided by the rate. And what do we do with the wind here? If it's flying into it, it's slowing it down. And there are our two equations. And one of the things we may or may not have mentioned before is that when you have a fraction equals a fraction, one of the techniques we could use is to what we call cross multiply, like so. So this is going to be 90 times r minus 20, and this is going to be 80 times r plus 20. And we just need to solve that. Okay, so we did a little multiplication, distribution, transposition, and we end up with 10R equals 3,400. Divide both sides by 10, we get R equals 340 miles. So, how fast is each jet traveling? 340 miles per hour. How did we do that? Well, we looked at the distance formula. We knew that time was the same, so we solved the distance formula for time. We get distance divided by rate. We know that time equals time, which is distance divided by rate equals distance divided by rate. So with the wind, it was 90 over R plus 20. The other was 80 over R minus 20. And we used the technique of cross multiplying. That got rid of our fractions. And there's our solution. Now let's see what they do. They're giving you a little setup here, showing you the various diagrams, which I think is nice. There's our little chart. And oh, I guess it was plane flying without the wind. I may have misread that. And I believe I did. Oh, I think maybe they made a mistake because as I read this again, it says the same time it takes the first plane to travel 90 miles, the second jet travels 80 miles. It says it's flying into the wind. That would slow it down. So I believe mine is right. And I've done many like this. But again, maybe the person that wrote it did it differently than the one who did the calculation. Anyway, okay, we'll go on. We're going on now to look at some problems involving proportions. And again, keep in mind on additional exercises, I do a lot of these word problems, not just one, but a variety of them. Now, when we do problems of this type, they're showing us, and again, I don't like the way they write their proportions. I like to write them A is to B as C is to D. And again, we said one of the techniques you could use is cross multiplication. A times D equals AD and BC. Now we say the A and the D are the extremes, and the C and the B are the means. And we say in mathematics, the product of the extremes equals the product of the means. And that's one of the proportional things. So if you know these two numbers and this number, you just divide both sides by D here, and A equals that. Okay, but let's see something in action here. So we're going to look at triangles here first. And instead of my drawing them, we will write them out here. Okay, there are our similar triangles. Now notice we have A side is 7, So let's start to set up our proportion here. A is to X as B is to Y. So now we can fill stuff in there. A is 7. A is to 8 here. That's what X is. As B, we don't know what B is to 12. So 7 times 12, I believe, is 84. And that's going to be 8B. We're just cross multiplying. Now we're going to divide by 8. And we get B equals 10.5, I believe. 8 goes into 80 10 times, 4 left over, 10.5. So when X is 8, A is 7, Y is 12, and B is 10.5. And how did we figure that out? Through the law of proportion. Okay? Let's check it out here. Okay, they set it up the way we did, and there it is, 10.5. Okay. Now, here we're looking at something else. We have sample of hard drives. We have 186 hard drives. In fact, I'm going to put it here. Hard drives. We use the letter H. They're expected to contain 4 defective. So 186 hard drives, 4 defective. Now, if you have this many hard drives, how many would you expect to be defective? And again, you set up a proportion. And the key to proportion is hard drives to defective. Hard drives to defective. Where students sometimes make an error, they'll reverse this side. And of course, it doesn't come out anymore. So it's going to be 186D equals, and 4 times 2 is 8. 4 times 0 is 0. 4 times 3 is 12. 4, and we have that. Now we're going to divide both sides by 186. And we get D equals, I'm going to get my trusty calculator here, 5208 divided by 186 gives me 28. So how many defective drives would you expect in this total number? And the answer is 28. How did we do it? We read our problem carefully. We set up hard drives to defective one. These were the total number of hard drives we now have. How many would you expect? We use cross multiplication, and we have our answer. Now notice they put defective drives over total drives. That's okay, as long as they're done the same way. We get the same answer. And 28 is our number. Okay, Now, here's a typical kind of problem you might run across where they have uh, ecologists are studying populations. You can go to a lake and pull out so many fish, tag them, put them back in, a later date, pull them out, how many are tagged, how many are not tagged. It's the same type of thing here. So let's read and see what they're looking for. To determine the number of humpback whales in a pod, a marine biologist using tail markings identifies 35 members of a pod. Okay, so we're going to start our thing here. We have 35 members of a pod that were tagged to our overall population. So we tagged 35. Several weeks later, 50 whales from the pod. So that's going to be our total population here, 50. And the key is, how many of the 50 are tagged? Well, 18. So we tagged 35. We now, a later time, some weeks later, we see 18 out of 50 that we see. So we could say that that would be the other members, or it might be our total population. So again, originally tagged, later that we saw tagged, out of the number cited. We're going to cross multiply, and we get 18p equals, use my calculator again here, 50 times 35 gives me 1750. I'm going to divide both sides now by my 18. So my population of the pod is going to be that divided by 18, or about 97. So how many members are in this pod? And it's approximately, because it was a decimal fraction, 97. And that's how we found it. So again, these are the tagged out of the whole population. Then we cited 18 tagged out of the numbers cited. We cross multiply, and we get about 97. Okay, and that wraps this one up. Again, there are many more problems worked out under additional exercises.